Hello, friends. Welcome everyone to this month's webinar Matchmaking for JVMs, How to Pick the Perfect GC Partner. See, friends, in this session, we are going to be talking about what is the right GC algorithm for your application, how to pick the right one, right? So, so we try to do something a little bit fun, right? So, here is your application, and here are some of the algorithms available in OpenJDK. What is the right one to pick, right? See, some algorithms we have looked up here very old, like CMS has been deprecated, so we are making it look very old. And there are some very new GC algorithms like a ZGC, right? So, so we are trying to show some difference in this opening slide. Okay, so let's get started. Okay. See, friends, if you have any questions, feel free to put it in the chat. I will answer at the end of the session. Okay. See, friends, choosing a GC algorithm is just like choosing a life partner, right? Why do we say that? See, because um, we live with our life partner under the same roof. Similarly, our Java applications, they coexist with garbage collection under the same roof, which is a JVM, right? They both coexist together under one single roof, right? Which is our JVM. And similarly, there is a lot of commonalities in between a GC application, in between me and our partner, right? See, um, our application creates a lot of garbage, right? It creates a lot of mess, and garbage collector keeps cleaning up. Similarly, in real life, probably if we are creating a lot of garbage, our partner might be cleaning up. But sometimes we ourselves might have to clean up, and sometimes we may have to clean up the mess what the partner is creating, right? Uh, and then see if your application becomes very aggressive and starts to create a lot of objects, then the garbage collector also becomes very aggressive and it stops the application from running. It has to reclaim the garbage, right? So if your application gets aggressive, the garbage collector also will get aggressive, right? Similarly, in real life also, right? If we shout, we should be ready to hear back shout back from the partner, right? Uh, so the next one is, see, both our application and garbage collector compete for the same resource. In this case, CPU cycles, right? Application needs CPU cycles to process the customer transaction. Garbage collector also needs a lot of CPU cycles, right? So they may compete for the same resource. It is also very true in real life as well, right? So that's why we think garbage collector is a kind of a life partner of your application, and it has to be chosen with care for harmony within your JVM, right? Okay. So, friends, what is garbage, right? Let's start off this with this question. What is garbage? Some people say my talk is a garbage, right? But let's see what a garbage means. See, right? See, friends, all our application has a memory, right? That the memory size can be uh, 2 GB, 6 GB, uh, 20 GB, 100 GB. Even there are applications with half a terabyte, 1 terabyte memory applications are all there, right? But still, at the end of the day, they have a finite space. Even if you allocate 1 terabyte of memory, still that is a finite space, right? Let's see what happens when a new request comes to our application. Let's say when a new request comes to our application, let's say new sign-on request comes to our application. This request is going to come and it's going to create tons of objects in memory. See, just to service a simple vanilla sign-on request, today our modern applications are creating tons of objects, thousands of objects. Say, for example, when a new request comes, I'm creating HTTP servlet request, HTTP servlet response. It has its own object hierarchies, right? And then a session, filter. And then once it comes, then I'm creating a manager object, uh, data access object, DAO objects. And now I'm checking out a connection from the connection pool, which is an object. and then I'm making a call. A database is giving back a record, which is a result set. And now I'm massaging the data. So we are creating thousands of objects just to service a one simple vanilla request. So I created all these requests. Now I found whether this customer is authenticated or not authenticated. I respond to the request. What came in? Request went away. Now what will happen to all these objects that got created? These very highly valuable objects, which was created just to service the new incoming request, will now become garbage because there's no more reference to it, right? It created, it serviced, it is done with this job. Now it has become garbage. So this garbage has to be removed from the memory. How is garbage removed from memory, right? See, friends, like uh, 3-4 decades back, for exactly 3 decades back in those days, the developers, as developers, we are responsible for writing the code to evict the objects from memory, right? See, today as a Java developer, we only create objects. I only say new customer object, new account object, new array list object. I don't write the code to evict them from memory. But back in those days, before Java, developers has to write code. They have to manually create and they also have to deallocate the objects. Think about it, even if they forget to deallocate the object in one single method or in one single use case, that is good enough for those objects to build up. And those objects will build up in memory and you will get out of memory error. So in fact, like if there are some C++ developer, one C++ developer was telling me, back in those days, he told in a funny tone, once we write the code, it is guaranteed that there's going to be having a memory leak. See, he told it in a sarcastic, funny tone, but it was very pervasive. That kind of tells what's going on. So in 1995, when Java came, Java promised automatic garbage collector, automatic garbage collection. It told to the developers, allow developers, you don't worry about reclaiming the objects from memory. As JVM, as a runtime environment, I will take care of removing the objects from memory. I will do it automatically. So you focus only on creating the objects. I will take care of removing the garbage from memory automatically. Developers loved it, so they can focus more on the business code. Management loved it because there is a less out of memory error. So it really picked off the automatic. See, even before Java, even in 1962, there was a language by name Lisp, I think. It had automatic garbage collection. That was the first language to have it. But once Java came, it really championed it. So since then, 1995, all the modern languages that we have today, be it Python, Go, .NET, all of them have this automatic garbage collection, right? So this automatic garbage collection is a very good feature. It's a very nice thing, right? I really like it. But it has two side effects. What are the two side effects? So the first side effect is it pauses your JVM. When a garbage collection run, it stops the JVM because it has to mark what are the active objects and it has to remove the unreferenced objects and it has to compact the memory. To that it pauses. So if your customer says, oh, your application was responding properly, but it paused for a few seconds and then it started running properly, most likely garbage collection is running in the background, right? This is the first side effect. And friends, the second side effect is this garbage collection consumes enormous amount of CPU cycles. It consumes enormous amount of CPU cycles. Say, because my application is creating millions of objects. So the garbage collector has to examine all the millions of objects it references to see what is active and what is inactive. It is a heavy CPU consuming process. Say, approximately, let's say if your application CPU consumption is 60% in your container, probably more than 30-40 percentage is consumed by garbage collection, right? So these are the two primary side effects of this automatic garbage collection, right? So friends, so when it comes to this garbage collection tuning, right, or garbage collection study, you need to understand I'm basing my measure against what metrics, right? See, there's this famous saying, you cannot optimize what you cannot measure. So if I'm going to look for what is the correct GC algorithm for my application, you need to understand what is the metrics I need to be using to base my measure against, right? So when it comes to garbage collection, there is three KPIs, my friends. What are those three KPIs? So the first KPI is latency. That is, when your garbage collector runs, it pauses the JVM. So you want to study what is the pause time, right? So here we report what is my average GC pause time? Okay, it is 34.7 milliseconds. What is my max GC pause time? That is, you don't only study only the average, you also want to study the max. Because say suppose you are promising some SLAs to your customers. Say I'm going to respond within 500 milliseconds with a transaction. Then you cannot have an 1 second pause time, right? So you want to understand the average and as well as the max, and also you want to also understand the distribution of the pause time. Okay, within 0 to 200 milliseconds, how much events got completed. So you want to understand this. And then the second metric when it comes to garbage collection study is the throughput. So friends, what is throughput? Throughput is basically a cumulative time. That is, say, take a 24 hours period, right? And it as throughput is reported in percentage. So if someone says my application GC throughput is 98 percentage, what does it mean is this application is spending 98 percentage of its time in processing the customer transactions and 2 percentage of time in processing the garbage collection activity, right? So that it is the throughput is basically I have to see it in a cumulative period. Okay, in 24 hours period, how much time my application is spending in processing the customer transaction and how much time it is spending in processing the GC activity. Latency is basically one single event's duration. Throughput is the cumulative time. Okay. The third one is the footprint. See, friends, the garbage collector adds a overhead to our JVM because the garbage collector needs CPU cycle. Garbage collector needs its own memory. So, what is the overhead my garbage collector is adding to my application? So, this is the third KPI. So, friends, these are the three KPIs, friends, when it comes to garbage collection study. What is my latency? That is, what is my individual GC's events time? Throughput or a cumulative time period. What is the cumulatively how much time I'm spending in the garbage collection? And the footprint, what is the overhead my garbage collection is adding to the JVM? So these are the three KPIs. But friends, there is one master KPI for any tuning, not just to GC. For any tuning, there is one master KPI. It is the response time. That is what is your customer facing response time, right? This is what the most important thing. I can do whatever internally, but what is the final time the response is landing on the customer's machine? That is the most important one, right? Okay. So now we understood these are the KPIs. Now let's go into when I'm going to do the GC tuning, right? When I want to select what is the right GC algorithm for my application, first you need to define what is your goal going to be. What is my goal? Say similarly, like when you're trying to select a life partner, you may want to set some goals, right? Like whether the partner has to be flexible, whether it has to be shall be pretty. There are several things we may look. Similarly, when selecting the garbage cluster, you need to select what is your goal going to be. So, what are the goals? So, the first goal is see, there are three goals you can set, right? But the first goal is I want to say my application's response time has to be low. See, friend, there are some questions, answers being raised. In the case, put your questions in the chat. I will answer at the end of the call. Put it in the chat. I will answer at the end of the call. So, first goal can be I want my pause times to be very low. Say, suppose, for example, my friends, you are building a trading application. In trading application, even 100 millisecond GC pause time could be very high, right? Because the stock trades has to happen in millisecond. There I cannot have an 100 millisecond pause time. So there a predictability and ultra low latency is very important. So if you're building a trading applications, you want to say my pause times has to be very, very low. That can be your goal, right? And then another goal can be I'm interested in a high throughput. I want a high GC throughput. Say for example, say I'm running a batch application. Say my batch application starts after my critical business window. Let's say it's starting at 6 p.m. once all my regular business is over, starting at 6 p.m., and it starts to run. The goal here for my batch processing is to complete it as early as possible, right? So say suppose starting at 6 p.m., I want to complete it before 9 a.m., before my next business day starts. So my focus there has to be, I want to complete it very quickly. My batch has to run quickly. So there you want to look for high throughput. So here in if it's my batch application, I don't care if one single GC event, if there's one single GC event takes very long time, it is okay. I'm fine. My goal is I want to complete it quicker. So that should be my goal. So here, if it's a batch application, your goal has to be high throughput, right? And then the third um, goal, what you can set is footprint. That is, I want to keep my GC overhead very, very minimal. Say maybe I am running on a very constrained infrastructure. I am building IoT applications. I am running on a mobile devices. So there I cannot have a lot of GC overhead. So there I want to keep it very minimal. I want to keep my overhead very minimal. So in case if the processes are higher, I might be okay. So you want to make a trade-off. See, friends, just like in a life partner as well, we cannot expect everything, right? That kind of human being does not exist. We need to learn to live with imperfections, right? Similarly, in your goal, you need to define what is my primary priorities. Oh, if I'm a batch application, it's very clear, I want to complete it as quickly as possible. If I'm running on a very small devices, then my GC footprint has to be very small. GC overhead has to be very small. So based on your application, you want to come up with the goal, prioritize them, and then based on it, go and select your GC algorithm. And these are the three goals what you can select, right? But if you're building a server-side application, right, there we have a lot of memory and GC overhead is not that much either. So if you're building a server-side application, I can always eliminate footprint is not my goal. If my GC algorithm is going to take a little bit more memory or CPU, I'm okay. As long as my pause time and throughput is better, I can go for it. So you want to come up with what is the goal and you should be willing to take trade-off. Okay. So now let's see what are the available GC algorithms are there starting in Java 11. How many GC algorithms are there in Java 11? Right? Let's look into that. So friends, there are 7 GC algorithms in Java starting from Java 11. What are they? Serial, parallel, CMS, G1, Shenandoah, ZGC, and Epsilon. There are 7 GC algorithms. Friends, here let's eliminate few algorithms. We can eliminate serial GC. Friends, serial GC was the default GC algorithm in JDK 1. At the time it was single-threaded. This is a single-threaded algorithm. At the time the Java was in infancy state. So it was okay. But now modern compute it has a lot of CPU cycles and very beefy. So we don't have to select serial algorithm in 2025. We can eliminate it, right? Similarly, we can eliminate CMS, the concurrent mark and sweep algorithm. The reason is this algorithm has been deprecated in Java 9 and it has been removed from Java 14. It has been removed completely from Java 14. So even if you're running on any version before Java 14, you don't want to touch CMS because it is removed. Why do you want to go for a version which has been removed? Okay. See, friends, I'm putting serial and this Shenandoah in a shaded red, not in a full red. The reason the Shenandoah, if you want, you can use it. See, Shenandoah was initially developed by Red Hat, and then it was handed over to Amazon. So it is not supported by Oracle. So if you see a special value in it, go for using it, right? But it is with specific vendors, right? So I don't know how well it's going to be supported. It's going to be continued. But if you see a value, please go ahead with it, right? So friends, and then I'm eliminating epsilon as well. See, epsilon is basically a no op GC. That means it is non-operational. algorithm at all. It is a no op. That is, it doesn't do any garbage collection. It's just only, it can configure only for experimental purpose or academic purpose to study how a JVM performs when there is no garbage collected, right? So friends, if you see, out of the 7 algorithms, I have eliminated 4 of them for you. So you need to pick only from these three: parallel, G1 and ZGC. So typically in OpenJDK, only these are the three choices available to us: parallel, G1 and ZGC. Okay. So from these three, let's narrow down what to pick. Friends, for this, I'm going to be using the GC algorithm performance comparison study, which was done by Stefan Johansson. He is a principal engineer in Oracle. So this is his blog page. He writes very interesting blogs, very insightful blogs. So you can take a look at it. Right? So the next 3 slides is coming from Stephen Johnson's blog. I'm sharing with you here. Okay. See, Stephen, what he did was he conducted the Oracle. They conducted a study of these 3 algorithms. That is parallel, G1GC and ZGC on this spec JBB benchmark. So friend, this is basically a benchmark, a well-known benchmark. It is a business, it is a kind of models Java server application with a workload, with a business workload. So it is a common benchmarking. So on this, they tried these 3 algorithms and they have shared the result. And they have used the heap size as 16 GB, right? See, our application heap size may vary. Some of them we are running on 2 GB. Some of them are running in 1 terabyte. So this is, you want to take it. So you want to conduct this study for yourself to make a decision. But I'm sharing you the results of Oracle, right? And they enable the large pages so that the pages are loaded into the memory, right? This is with this setup they conducted. Let's see what is the performance results of these 3 algorithms. Okay, so friends, so this is the so friend, this is the, wait a minute. Okay, so this is the throughput of the algorithms across JDK versions. So if the throughput means, if the higher the throughput, it is better, right? Look at this. The parallel GC algorithm, it is like in JDK 8, in Java 8, it was 100%. And in JDK 17, it is like 130%. And JDK 21, it is 130%, same percent. See, from in between JDK 8 and 17, I think there was like a 7 years gap. So in the time, a lot of improvements and innovations happened and they really scaled it, right? That's why you see this jump. But in JDK 17 and 21, I think there's only a two years gap, so that you don't see that much leap. And this is the throughput performance of G1GC algorithm. You can see it's 100%, and it is 142% and 145%, right? So for their spec JBB, this is the throughput, and the ZGC is not having that great throughput when compared to other algorithms, right? So now this is the pause time measurement, right? So here, if the pause times are lower, it is better, right? So if you see in the parallel GC algorithm, these are the pause times. Like it is 107 milliseconds in JDK 8, 66 milliseconds in 17, and 66 milliseconds in 21. G1GC is more or less in the same arena. And here, the ZGC, you see it is fractional, right? It's ultra low latency. But my friends, here is an observation I would like to share with you, right? See, you want to do this benchmark on your environment. See, what is ZGC? ZGC, they have made a lot of improvements in starting only. This is my personal opinion, right? It's not reflective of what Oracle is saying. I saw a lot of improvements. ZGC has good improvements starting from JDK 21. It wasn't the case in 17, at least in the test that I conducted, right? And then another thing also, friends, the ZGC does something very clever. What they're calling it as an allocation stall. What is allocation stall is, if they see a thread which is creating a lot of objects, they are stopping that particular thread from creating the objects, right? They are stopping the thread so that the thread is stalled. It's not able to create the objects. So just that particular thread is stalled, but other threads are able to function and they're able to progress forward. But still, that thread, if there is a customer waiting, he is not going to get response back. So that will kind of also degrade. So that is not accounted into this throughput calculation, what they made by here. So you want to take that into consideration as well. Okay. Okay. So now this is the footprint. This is the memory overhead, right? How much they are taking. What is the footprint overhead they are taking? But because of switching to G1, G, because of the algorithm, what is the overhead of each algorithm? So if it's lower, it is better. You can see the G1 is having a low overhead. Say suppose you are building IoT solutions, running a Java application running on a small devices where you want to have very less overhead. Probably G1 in JDK 21 is a better option for you. Okay. Whereas the ZGC has a lot of overhead here, right? When compared to the other algorithms. Okay. So now, friends, I'm moving along. Okay. See, friends, this is an flow chart I have put together, which can be a dumbed down version of me trying to explain what algorithm you want to use, how to go about choosing the algorithm that you want to use. See, first you want to see what is your goal. If your goal is to keep your footprint as low as possible, that is overhead caused by GC, you want to keep it very low, then go for G1 GC. Whereas if your focus is to achieve high throughput, that is, I'm running a batch application. I want the batch application to complete quickly. It's okay to have an occasional long process, but I want to complete very quickly. Then go for parallel GC algorithm. That will be my first choice. If this doesn't work, then try a G1 GC. Okay. So now, but let's say if your focus is on low pause times, friends, try with if your heap size is less than 64 GB, try if it is less than 64 GB, go for using G1 GC algorithm. But if it's going to be more than 64 GB and if you're running on Java 21 and above, use ZGC. This is my personal experience I'm sharing with you. But of course, you want to conduct the tests on your environment, on your application, and then come to a conclusion. Don't base anything on this flowchart, right? Okay. So now moving forward, how to conduct the test and how to find the right GC algorithm for my application. What should I need to do? So I want to be sharing with you right tools, tips, and tricks to achieve that. How to conduct the test. What are the best practices? What are the tools, right? So that's what we are going to be discussing in next few minutes. Okay. So now, friends, look at this. We discussed that these are the KPIs, right, earlier. So what are the KPIs against which I will need to test my GC performance? The latency, what is my individual events pause time, and throughput. Over a time period, what is the cumulative time my application is spending on processing the customer transaction, and also how much it's spending on processing the GC activity. And what is the overhead my GC is adding to my application. And the master metric is what is my response time, right? These are the metrics. Okay. So now, how to source these metrics? Okay, now these are the metrics. How to source these metrics? Friends, the best way to source these metrics is from the garbage collection log. Garbage collection log gives all these metrics in a very pristine format, right? So how to enable the garbage collection log? You can enable the garbage collection log by passing these JVM arguments. If you're running on Java 8 or before versions, pass these arguments. Give the file path. So the JVM will start recording all the GC events in this file path, whatever you mentioned. And if you're running on Java 9 and above, this is the file, pass this argument to your JVM. and then pass this and restart. So you will capture the GC log. Friends, a lot of people ask, oh, what is overhead in enabling the GC log? Right? Friends, enabling the GC log adds almost zero overhead. It's not even noticeable. And here is a white paper we have published which showcases what is overhead it adds. It's almost negligible. You cannot even notice it. But it becomes very vital not only for GC selection, it is also very helpful to troubleshoot various memory problems, to troubleshoot various production problems. We have discussed about troubleshooting production problems with garbage collection log in our previous webinars, right? Okay. Okay, once you enable this GC log, your GC log is going to look something like this, right? It's going to have a lot of numbers and text. You can learn and train to read it in a from a text editor, or else what you can do, you can also use tools, right? Here are some of the tools, my friends, that are available. You can take your garbage collection log and upload it to these tools, and then you can see the results, right? See, I've listed some of the available tools, right? You're welcome to choose whatever is the best one. You don't want to take my opinion to know what is the best one, but if you ask my opinion, it will be biased. But because we make GCEC, of course, I'm going to be very leaning towards GCC, but I will let you decide whatever is available, whatever you like, go ahead and use it. Okay, so now what we will do, we will take a sample GC log and then let me show how to gather these metrics from the log. See, friends, this I have this GC log file. So now let me go to GCEC tool, and then so this is the tool. You can copy and paste the GC log file here, or can use the API for doing a continuous monitoring or CI/CD integration of a GC log. But now what I will do, I will upload the GC log file. And now once I upload, the tool is going to analyze, and then it's going to generate me a report highlighting what are the issues. Say it analyzes the GC log and tells, oh, there's a memory leak, oh, there's a poor throughput. And what it does is it also gives you the recommendations, pointed recommendations on how to improve the GC performance. Oh, there you need to increase this GC concurrent GC threads. Or you want to increase this initiating heap occupants percentage. These all will improve your GC performance. It gives you these kind of recommendations. But coming to how do I source the metrics, friends? The metrics we saw, right? What is my latency? What is my GC pause time? This is one of the key metric. It is here. It's reported for you. And then what is my throughput? It is reported here. And what is my CPU overhead that is added because of this garbage collection? It's printed. The metrics what you need is here for you, all the key metrics. But the response time, the master metric is not going to be available here, but that is something you want to be using your access log or your APM tools to get it, right? The overall transaction response, application response time will not be present in GC log. You need to get your other monitoring tools to get it. Okay, so it has these kind of memory visualizations. Okay, how is my heap behaving? I can see various graph. What is my pause times? Oh, here there's a cluster of GC pauses are running. How much bytes are getting reclaimed after every analysis? I get to see all of them. So there is more and more fine-grained metrics are available, but I'm not going to bore you with all the details. What I need for tuning, for measuring the performances, the KPIs, I can get everything from here. My throughput, CPU time, and then latency. I can get it. The response time is not going to be available here. You're going to get it from the from your monitoring tools or access logs, right? Okay, so friends, how we how do I go about for tuning exercise, right? I'm going to be sharing my secret sauce. So this is what people engage us to do the GC tuning and optimization. I'm sharing my secret sauce with you today. This is what I do. I'm sharing with you. This is a thing I learned by myself. I built it, refined it over a period of time, but now I'm sharing with you, right? See, friends, what I do is to conduct these kind of GC exercises. I have this kind of a GC tuning worksheet. This webinar presentation deck will be shared with all the attendees. So here is a template sheet, right? What we do here I document what is my GC algorithm I configure. Let's say for in this case, I'm using the parallel GC algorithm, right? And what are the JVM arguments, GC arguments I'm passing? I mention it here. And then here I document the KPIs. What is my average pause time? What is my max pause time? What is my GC throughput? What is my CPU overhead? And then what is my average response time? And what is my 19 percentile response time? I document all these things here. And then here I place my report URL. That is I place my GC report URL, right? So that if I want to see the details, I can click here and I can go and see the report URL. I keep it. Now what we do, we change the GC algorithms. Okay, I tried with parallel. Now I'm going to switch to G1 GC. Then I'm going to try with ZGC and document the readings, right? Say, for example, I can share with you a live example of what we did for one customer. You see, here we have this one setting and we have documented it. And then here we document other metrics as well. Like see, we tried multiple iterations. Okay, we tried with different algorithms with different settings, and we are documenting it in a worksheet like this. This worksheet template is going to be shared with you. So okay, finally I find, okay, this is the best algorithm giving me the best results based on my goals. Then I select this setting and then I go live with this. So friend, this is all we do for DC tuning, right? And it has worked and it delivers, right? So you can also follow this strategy if you want to. Okay, so now coming back, okay friends, so using this flowchart and using this methodology, you can select the GC algorithm. But friends, along with this, how to come up with some, okay, now how to come up with some special configurations, setting initial heap occupancy rate. Do I need to increase my concurrent GC threads? How do I do all those things to get even achieve better results? Friends, for that, here is a blog link I'm sharing. It has also a video. You can take a look at. I'm sharing some specific tips and tips which will help you to refine. Okay, I selected this algorithm. Within that, what are the sub arguments I want to pass to optimize the performance? So you can pass this. You can follow the instructions given here to refine it further. Okay. So friends, now this brings a question. Why do I need to do the GC tuning? Okay, what is the advantage of it? Friends, the biggest advantage is when you optimize your GC performance, you are going to optimize your entire application's performance, right? See, look at this. This is a real case study of one of the largest car maker in the world. He's one of the largest car maker in the world. So this is in their middleware platform, which process several millions of transactions. So look at this. This was their baseline average customer facing response time. It was 1.88 seconds. Customer facing response 1.88 seconds. And here is the second column. It indicates how many transactions are timing out. Like 0.7% of transactions are timing out because it was going more than 25 seconds. Friends, just by doing the GC setting changes, the changing algorithm, changing the settings, look at this. In few iterations, just like on the Excel spreadsheet we saw, they were able to reduce the response time from 1.88 seconds to 0.95 seconds. This is, my friends, a 50% improvement, right? 50% reduction. Think about it, friends. There are a lot of engineers in this call. We have very long career history, rich experience. Take a pause right now. Look back in your career. How many times in your career you were able to optimize your entire system-wide response time by 50%? I'm pausing. Think about it. How many times you are able to do, or how many times you have seen it to be accomplished? Very, very few times, if at all, if it would have happened. And that too, what we might have done, we might have restructured some SQL queries, which was taking very long time to complete. We optimized it and now we got back. But now, friends, with GC, it is zero code change, very low risk, no code refactoring, no architecture changes, no infrastructure changes. Just by changing the GC settings, you can achieve phenomenal performance improvements just by tinkering with your JVM arguments, changing the GC algorithm and changing the JVM GC settings. It's a phenomenal improvement what you can bring. And friends, let me also tell, This GC tuning skill is is a timeless skill. That is what I mean to say. Even AI applications are getting very predominant, very pervasive. AI applications are going to run in Java, JVM. They demand more objects, more memory, more CPU cycles. Their GC tuning is going to become even more profound, even more impactful. So this is a very wonderful skill to master, right? Okay. Uh, there are some more case studies, right? Here is another case study which I would like to highlight. See, Uber, one of the very large ride-sharing car app, they did a GC tuning exercise and then they reduced their CPU consumption by 70,000 cores. So they were able to reduce a few $1 million in their computing cost because garbage collector takes a lot of CPU cycles. When they tuned and they reduced that footprint, they were able to reduce the CPU consumption and they were able to ultimately reduce the computing cost. The details about it can be found here in the link. Take a look at it. The more case studies are available here. So GC tuning is a valuable skill. You can make profound impacts. Right? You're welcome to practice it and bring great success to your organization. And friends, in case if you're not bored with the session and if you want to learn more about JVM tuning and troubleshooting, you may consider attending my online JVM performance masterclass. It's a recorded session. It's available. You can review at your face. The link for that is available. You can register and then you can it may be helpful. Okay, friends, with this I'm coming to end of my talk. Thank you everyone for attending this month's webinar. We'll connect back with you with another interesting session.